1, 2, buckle my shoe. 3, 4, 3, 4, 3, 4. See, I forgot. 3, 4, what is that? 1, 2, buckle my shoe. 3, 4. Forgot. 3, 4, what comes after that? 3, 4. Ah, yeah. See, it's been a long time. I have not sung this song, okay, and it's been a long amount of years. So I remember singing this song when I was in class A or B. So a lot of time has passed by. So if you know the lyrics, what follows after 3, 4, kindly comment in the comment box and let me know. Okay. So hello, my dear students. I welcome you all to this channel. My name is Benatang Paton, and together we learn here. Okay. So I welcome you all, those who are tuned in for today's class. In today's class, we'll be learning about well, I've already written something here, okay, symbols, components. So I'll tell you what it's gonna be. In the first session, okay, in the initial minutes, we'll be learning about some common state symbols or standard symbols, okay, which are required, because in this chapter we'll be learning how to draw circuit diagrams, okay, electric circuits and all that. So the knowledge of this is very important, okay. You need to know this, and it's very easy, okay. It's very easy. There are still some of you who are confused with this, so it's very easy. So in today's class you will learn, okay. I'll teach you, so leave it to me, and after that we'll go to Ohm's law and we'll end up the video from there. So today's class will be about the following topics. So without wasting any time, okay, let's go to the topic. Let's jump to the topic. And like always, a reminder to always grab a notebook, grab a pen or a pencil, and please write down, okay. These are valuable notes for you. All right, so should we start? Yes, so let's start. So let us this is exactly copy pasted from the textbook, okay. I just copied it from the textbook and I've drawn it to save time, okay, because these things, okay, take a lot of time while drawing, and plus if I draw live, then the lines will not be straight, so it will look very messy. So okay, for which I have drawn early. Now the components are all written here, okay, on the left side, and we will draw the symbols. Okay, we will start with the first one, which is an electric cell. So an electric cell, remember cell, okay, class, cell. So a cell is the smallest, okay, this is the smallest battery, you can say, okay. We have batteries, but batteries are big combinations of cells. So okay, we start with cell, okay. I will recorrect myself, okay. I'll take back what I just said, which is a cell is the smallest battery. We will not say like that, okay. We'll just start with cell. Just like cell is the building block of life, okay, we'll start with cell. So everything starts with cell. That is way better, nah? Everything starts with cell. So you have to know how to draw a cell. So how to draw a cell? Very simple, okay. So a cell is the smallest charge, okay. A cell is the smallest charge. Let's define it like that. A cell is the smallest charge. So charge plus minus, now it has the power to give you a potential, okay. So a cell is the smallest, okay, device which can give you a potential, okay. Let's define it like that. How many times have I changing this definition? So let's take the final one, okay. A cell is the smallest entity which can give you a potential. I think that is more accurate, nah? Because cell is going to be a culmination of cell is going to be a battery, and what does battery provide? Batteries provide potential. So let's define cell like a cell is the smallest entity which can generate a small potential, okay. So how to draw a cell? One long line, okay, and a small line. So easy, okay, my dear students, so easy. One long line and one short line. The long line is the positive and the short line is the negative, okay. They are parallel with they are drawn parallel, and then sideways you draw, okay, a line like this. This is a cell. So easy, isn't it? Okay. Next is a battery. So next is a battery or a combination of cell. Combination means what? Many, okay, many. So here I have, let me use this, show you these 3 markers. So I have 3 markers with me. Marker 1, marker 2, and marker 3. Okay, a combination of marker. This is called a combination of marker. Single is a cell. A combination of cells will be called a battery. So together these 3 will be called a battery. If these are cells, then the combination of these 3 cells will be called a battery, okay. So remember this. So a combination of cells is called a battery. So this is a cell. So minimum we have to draw 3. So let's draw 3 cells. So this is first cell, okay, long one is plus, short is minus, then again long one, short one, long one, short one. This is plus, this is minus, and don't forget the line. There you go. Okay, this is a battery. Minimum 3, more is up to you. You want more, you can put more. Okay, you can put more, so it's up to you. Okay, but minimum draw 3. Okay, 2 is actually less, so at least draw 3. Next is what? Plug key or switch. So plug key or switch. Now there are 2 types of switch, okay, on and off. So we'll start with first on. So let's start with on, and then let the bottom one be off. So let's start with switch on. So on switch means, okay, plug key or switch on. That means there will be a bracket, okay, and there will be wires here. On is not. On means the key is inserted. So this black dot, okay, this is plug key or switch on. Okay, then plug key or switch off. Switch off means, okay, switch off means everything is same except in switch off the black dot is not there because the key has been removed. For example, okay, let this marker cap. So if the key is inserted, it will be like this. So the top view, if you observe from the top, from your angle, you can see this black thing is not. Okay, now what if I remove this one? Suppose it was here, let's say, and I remove this one. So I remove this one, I have removed it. Do you see the black thing? No. Why? Because the key is with me, I have removed it. Alright, so this is called off or, okay, open. This is called open or off. So remember, off means open, on means closed. Okay, this is on, and in on the key is inserted. Alright, so this is the top one is on when the key is inserted, and this is off. Alright, next is a wire joint. So how do we draw a wire joint? So a wire joint, so there should be at least 2 wires. So let's say one wire is going like this, okay, it's headed in this direction, okay, and the other one, okay, it's a wire joint, so the other wire should come and touch this. So let me draw like this, okay, and then they are touching here. So wherever they are touching, to show the joint, let's make it a little black like this. This is how you draw a wire joint. Okay, this is one wire, this is the other wire. Okay, this wire is going like this, the other wire is touching the this wire, and they are joined. Okay, they are joined. Okay, they are joined. Then moving next, wires crossing without joining. Wires crossing without joining. Here the wires are touching each other. Okay, now we will draw wires which are crossing but without touching. So how we will draw? So the same wire, we'll draw this one just like in the first one. Okay, let's bring this one higher. So let's draw in the middle. Okay, all right, so this wire is heading towards the side. Okay, then one wire I will draw heading from up to down. So this wire is heading from up to down. Okay, but this is without joint, isn't it? So it will be shown like this. This is how you draw. This is how you show a wire, okay, which is crossing but without joining. That means this wire and this wire, the up to down wire and this horizontal wire, they are not touching each other. All right, they are not touching each other. Next one, electric bulb. Very important. This is a very important component. Okay, the important components here are this, and this. Okay, these are very important. Okay, an electric bulb, how will you draw? Very simple. Okay, there are two diagrams given in your textbook. We will draw the simplest one, which is just draw like this. Okay, and then draw like this and do. And if you want to put it, do this one. Finish. This is a bulb. Okay, it's very simple, isn't it? Okay, very simple. I was also drawing a very difficult one, but just recently, okay, I have learned how to draw this one. Or also, I was drawing a very complicated bulb. Okay, so I will not teach you that. I'll teach you the simplest one because this is the easiest one to draw. Okay, next one, a resistor of resistance R. So how to draw resistance? We will be discussing what resistance is. Okay, my dear students, do not worry. Okay, there are lots of lectures, videos lined up. Okay, one by one, like I told you. Okay, I will make sure that I teach every topic of science. Okay, so it's my duty and responsibility, so you will be taught everything. Okay, rest assured, I'll teach you everything. So a resistor of resistance R. So resistance, how do we draw? Like this we draw. Okay, this is resistance. Then variable resistance, or which is known as rheostat. So rheostat, variable resistance, how do we draw? So it will be like this only. Okay, but then here there will be like this. Okay, it can be like this, or if you want to modify, you can also do like this. Okay, anyone, both are correct. Ammeter. Now class, you tell me. We have already discussed what ammeter is. So anybody who can tell me what ammeter is? An ammeter is an instrument to measure, fill in the blanks. What do we measure with ammeter? Yes, current. So ammeter, how we draw? We put a circle, we draw A in between, inside, sorry, and we draw the two lines. We can write plus and minus. This is how you draw an ammeter. Okay, very important component. Very important component. Let's circle, let's put star mark to those components which are very important. Okay, and finally, voltmeter. How do we draw a voltmeter? Okay, a voltmeter is drawn similar to an ammeter. The setup is same. Circle, inside the circle put V, line, wire, plus, minus. Simple. So these things, okay, my dear students, is what you have to mentally have a visual of all these symbols. Okay, it's very easy. Okay, it's very easy. Mentally you have to have a visual. Okay, whenever a teacher says ammeter and you are supposed to draw a meter, remember this figure, remember this visually. All right, so now can anybody tell me what a voltmeter is used for? Where do we use a voltmeter, and what does a voltmeter measure? Ammeter, current, very good. What about voltmeter? Tell me, what about voltmeter? Yes, do you know the answer? Yes, a voltmeter measures potential difference. Okay, it measures potential difference. All right, okay, now moving ahead. Okay, let's erase this, and now we'll do some definitions and discussions. Okay, so now we'll be using this, okay, these state symbols. Okay, whatever we have drawn, we're gonna use it, and then our discussion will include this. So from now on, these symbols are going to be very important, so make sure that you all, okay, study this and then remember this, because these symbols are very important. So let's just go ahead for the next topic. So now the next topic will be a circuit diagram. What is a circuit diagram? So define a circuit diagram, or let's say, what is a circuit diagram? What is a circuit diagram? This is an important question. Okay, so what is a circuit diagram? A circuit diagram is a schematic diagram. Okay, let's just write down. Okay, a circuit diagram is a schematic representation of an electrical circuit. A circuit diagram is a schematic representation of a electrical circuit using the standard symbols STANDART. My spelling of standard, is it correct? Is the spelling of standard correct? Okay, STANDART, I think it's correct, nah? I'm very weak in spellings, okay? So this is why every now and then I confuse myself with spellings using the standard symbols, or you can also write state symbols. Okay, anyone, both are correct. Since I'm weak in spellings, I will go for state symbols, because state symbol I will not forget. Standard, see, I got confused. Even now I have doubt, okay, whether this is correct. Okay, so a circuit diagram is a schematic representation of a electrical circuit using standard symbols. Okay, so what a circuit diagram is, okay, we'll just draw a circuit diagram. So a diagram which is drawn using the symbols that we have just studied, okay, to represent an electric circuit is called a circuit diagram. So let us draw an electrical circuit, and we will draw the electrical circuit using the help of those state symbols. So let's draw an electrical circuit. Now I'll tell you what an electrical circuit also is, okay, but first let us try to draw an electrical circuit. So to draw an electrical circuit using the state symbols, okay, we will start with first the battery. So battery, remember, not the cell but the battery a combination of many cells. So plus minus plus minus plus minus, minimum 3. Okay, then wires, we need wires. So this is the battery. I'll write down whatever state symbols we're using. Battery used. Then next, what? This is wires. So wires, this is wires. So wires also we're using. This is plus, this is minus. Okay, then we can always use an emitter, or can always use a plug or switch or key also. So let's keep the plug here. Okay, and then let's continue. So this is what? This is the key or the switch. Okay, this is also one of the components in the state symbol. So we have already used key, battery, 2 we have used. Okay, wire is here. Next we go ahead, and then what I will do, I can use a bulb, isn't it? So let me use a bulb. This is the other component. So bulb. So I'm using 1, 2, 3 components I've already shown you. Okay, then I go ahead and I can always use a resistance also. So I'm using resistance also. So I have shown you 4. 1, 2, 3, 4. 4 state symbols I have used. I'll use more again. Then we glide down, and then here what I can use an emitter. Okay, so an emitter, I am using an emitter. This is an emitter. So in this simple circuit diagram, how many state symbols have I used? 1, 2, 3, 4, 5. This is how you draw this is what is called a circuit diagram. Okay, a circuit diagram is a schematic representation of an electrical circuit, grammar should be correct, of an electrical circuit. So this is an electrical circuit, okay, using the standard state symbols. Okay, got it? Now let's define what is an electrical circuit. Define electrical circuit. Define electrical circuit. So what is an electrical circuit? Again, another very important question. Okay, circuit diagram is very important. Electrical circuit is very important. Okay, so many important points we are discussing today. Okay, so define electrical circuit. So how do we define electrical circuit? So an electrical circuit, okay, a closed and continuous path. A closed and continuous path where current flows is called an electric circuit, or simply circuit. So remember, if the question is define a circuit, just a circuit, then also the answer will be same. If the question is electric circuit, then this is the answer, a closed and continuous path, okay, where current flows is called an electric circuit. A closed and continuous path for current to travel is called an electric circuit. I'm giving you 2 variants. Okay, I'll repeat the second variant which I just said now. A closed and continuous path for current to travel. Here I'm writing flows, but flows, though you know now, flows means traveling only. Okay, so now flows means traveling only, moving only. So a closed and continuous path for current to flow is called an electric circuit. Is written here. Other definition, easy one also, a closed and continuous path for current to travel is called an electric circuit, or simply circuit. Okay, so this is an electric circuit. Okay, remember class, this is an electric circuit. Okay, a closed and continuous path. But now, is it really closed or is it open? Can anybody tell me? Look at this figure, the circuit diagram which you have just drawn, and can anybody tell me whether this circuit diagram is open or closed? How do I know this open or closed? You have to focus on this area. Pay attention to this area. Yahan dhyan do. Yahan dhyan do. Pay attention here. Look at this, and go and look at the state symbol and tell me, this is an open plug or a closed plug? This is an open, isn't it? That means this is an open. So here current will not flow. Remember, in an open circuit, current does not flow. Current will only flow when it is closed. So then we have to modify this figure. Okay, if I want to use this figure, okay, if I want to draw a figure to explain electric circuit, okay, then I have to make sure everything is correct. Just one thing, which is do not forget to make it close. So you can make it close by putting this dot. If you put this dot, that means the key has been inserted. If you remove the key, okay, then this black spot disappears. This black dot is the key. If you put the key, this is the key. If you put the key, you see the black part is not. If I remove the key, then this black dot will disappear. That means key is not there. So connection is broken. So current will not flow. So that means this is open. Current will only flow when key is inserted. So we insert the key. That means the black part is visible. That means key is there. If you see a black dot here, means key is there. So current will flow because current will come out from this part, from this terminal. We know na, current is something which travels from the positive terminal to negative terminal. We assume it like that. Okay. Whereas in reality, nothing travels from plus to minus. Actually, electrons travel from minus to plus. Okay, that we have already discussed, okay, in the previous lecture, potential difference. If you have not watched it, okay, if you are confused with what I just said, then kindly go and watch the previous video about potential difference. Okay, you will understand very clearly what I just meant by saying that nothing flows from plus to minus. In reality, in actual reality, it's the electrons which travel from negative terminal to positive terminal, and that is what constitutes charge flow. Okay, understood? So current flows out from here. We assume that current flows from positive terminal to negative terminal. So if the key is open, then current will not flow. So in order to make current flow, key has to be inserted. Then the circuit is closed and the current will get a path to travel. A closed, okay, non-disturbing, continuous flow for current to pass through. That is what a electric circuit is about. Okay, define electrical circuit. Okay, anyone, electrical circuit. I wrote electric circuit and I'm writing here. This is electrical circuit. I'm writing electric circuit. Same, electrical circuit, so make it electrical circuit, or it can be electric circuit, or simply a circuit. Okay, so three ways they can ask you, but the answer is same. All right, I hope you understood. Now there are two types of electric circuit. One is called closed, the other is called open. So two types of electric circuit. I'm writing down this so that this will serve as a notes for you. Okay, two types of electric circuit. What are those? We have the closed and the open. So we have the closed circuit and we have the open circuit. So closed circuit and open circuit. How is it? Now see, this is closed. Okay, open, how will it look like? So let's have a look at closed and open. So where do I draw? Should I draw it here? So let me draw here. Let me draw one side closed, the other side open. So this is the terminal, plus, minus, plus, minus, plus, minus. Let this draw like this. Then I can also draw like this. Okay, I've already shown you like this. Okay, but now I'll show you another one, how to know which is closed and open. So let's put dot here. The first one I'll show you will be closed. So closed will be like this. Okay, let's just draw one bulb here. Okay, so close, open, plus, minus, plus, minus, plus, minus. Now this is another way to represent close and open. So this is close. Now this is another way to represent close and open. Here, unlike this, okay, here this is for plug. This is for plug key. Okay, here this is wires only. This is wires only. So between these two dots, this link is here now. So this link, okay, this wire between the two dots, okay, so these two dots are linked by this wire, so current will get to flow continuously. So charge comes out from here and the charge will flow all the way. So this closed to the negative terminal. Whereas if you go here, this is called open. So charge comes up from here, so charge goes here, but then nowhere to go now. So charge has nowhere to go, so where will it go? It will not go anywhere, it will go back again. So charge is just here, charge can only move till here, and then it will go back, so nowhere to go for charge. So this is called open. So current will never reach here, so the bulb will never glow. So in order to make this close, this has to be pushed down, and it has to be, and this has to touch this one. And if this falls down and touches this, it will look like this. Okay, and if this is pushed up, then it will look like this. Okay, it will be down. If it is pushed down, it will be like this. It will connect, and if it is pushed up, it will be like this. So if it is pushed up, it becomes open. You can see open gap is here. Okay, this is why it's called open. And if this is pushed down, it will connect this. It will connect to this dot, so it will become closed. Then current will pass through, because current now gets a path for him to travel. Whereas here, current can only go till this part, and then it will just go back again, because the link is not there. Okay, so this is called open. All right, this is called open. If it is closed, then it is called on, and if it is open, then it is called off. Remember, okay? If it is closed, then it is called on. Why on? Because current flows. Current can flow now. That means it's on. The circuit, the current flow is on. So when I write on, which is very misleading and very confusing for students, when I say, okay, it is on when it is closed, students get confused. What is on when it is closed? I'm talking about this circuit. I'm talking about a closed circuit. Okay, current flow is on when the circuit is closed. Current flow is off when the circuit is open. So when the circuit is open, current flow is off. That means no current flows in the system. No current flows in the circuit. Are we clear? Are we clear? Yes? Alright. Okay. So if you are clear till this much, then we will go to the next topic, which is Ohm's law. O-H-M-S. Ohm's law. Let us discuss Ohm's law. A very important law, and it is very easy to understand. Okay, Ohm's law was given by a German scientist whose name was Georg Simon Ohm. All right, so he was a German scientist, and then he was the one who proposed this law, and now we are studying this law. Now this is a very important law. In this law, we talk about potential difference and current. Okay, so let me ask you this question. Is there a relationship between current and potential difference? What is your answer? Is there a relationship between current and potential difference? If you have watched the previous video, your answer will be a definite yes. You will say yes. Yes, sir. You will say yes. So there is a relationship between current and potential difference. Okay, so Ohm's law is about this, the relationship between current and potential difference. The statement of Ohm's law is like this. Ohm's law says that the potential difference across the ends of a conductor is directly proportional to the current flowing through the conductor, provided temperature remains the same. So let us write down the statement also. So the potential difference across the ends of a conductor is directly proportional to the current. The potential difference across the ends of a conductor is directly proportional to the current flowing through the conductor, provided temperature remains same. This is the statement which you have to study, my dear students. And this is a 3-mark question. 3 mark. It comes for 3 mark statement along with the derivation. Okay, so 3-mark question. It has been asked a very important law. Okay, so please make sure that you know this. Now let us try to understand this. So Ohm's law brings out a relationship between potential difference and current, or current and potential difference. Okay, so let us try to understand. Let us do a quick revision of what we have learned in the previous video. In the previous video, we were learning about potential difference. And what is potential difference? If I ask you, okay, my dear students, what is potential difference? Tell me what is potential difference. Please tell me what is potential difference. Is potential difference not the push? Is the potential difference not the voltage? Voltage is the push, is not. Potential difference means voltage. We have already learned this in the previous video. Potential difference is voltage. Voltage means push. So it can be a small push, a light push, or a strong push. Okay, now you tell me, if this is the charge electron here, okay, if this is the charge here, and if it is given a slow push, okay, now how will the charge travel? Will it travel very fast? No, the push is slow, so it will travel slowly. Okay, it will travel slowly. It will take more time. Okay, it will take more time to reach here also, so it will take more time, so it will go slowly. Okay, but on the other hand, if this is the charge and this time the push is strong, fast, then what will happen? This will go very fast, yes or no? So in a short amount of time, it will already pass through this zone. Okay, got it? So if push is strong, if potential difference is more, if push is strong, then what happens? Okay, more charge will pass through in a short amount of time. But if the push is slow, or if the push is weak, like this, then charge will travel slowly. Understood? So remember this. Okay, the more the potential difference, the more the current. The stronger the push, the more the current, the more charge will pass through. Okay, if the push is slow or less, then charge will be slow. Understood? So remember this. So potential difference is directly proportional to current flow. Okay, if the potential difference, if the push is strong, then more current will pass through. If the push is slow or less, then less current will pass through. Less charge passing through, that means less current. More charge passing through, that means more current. So there is a direct relationship between potential difference and current, or current and potential difference. Okay, if more current is flowing, for example, if more current, for suppose in 1 second, let's say in 1 second, okay, through this wire, through this area, okay, 1 2 3 4 5 6 7 8 charges are flowing in 1 second. Okay, in 1 second, okay, 8 charges are flowing. And in 1 second here, okay, 1 2, only 2 charges are flowing. Okay, now you tell me, okay, here more current is flowing, here only 2 charges are flowing, that means less current is flowing. More current, more charge, more current. Less charge, less current. So current flow is more here. Current flow is more here because charge flow is more. Current flow is less here because charge is less. So in 1 second, only 2 charges are passing through this. Okay, whereas in 1 second, timing is same. In 1 second, 8. Okay, 8 charges are passing through. Now you tell me, okay, where is more current? Here more current is not. Now how come in 1 second 8 charges are passing through? That's because the push that they receive was high. That's why in 1 second 8, okay, in 1 second 8 has passed through, whereas here in 1 second only 2 has passed through because the charges are traveling slow. So why are the charges traveling slow? Because the push that they got is slow, so the charges are traveling slow. But in this case, in the first case, in this case, here the push that they receive is strong, so they are traveling very fast. So here in 1 second, more charges are passing through in that given 1 second, whereas here, even in that 1 second, less charges are passing through. So is it not, now you tell me, my dear students, is it not directly proportional to the push? The amount of charge which is passing through the wire in a given time, is it not proportional to the push? It is. It is proportional to the push. Okay, so remember, this is what we have learned in the previous video also. I'm just rewinding because this is exactly what Ohm's law is about. Okay, Ohm's law is bringing a relationship between potential difference and current. Okay, which says that the potential difference across the ends of a conductor or a wire is directly proportional to the current passing through the wire. Okay, that means the potential difference across the ends of a conductor. As per the statement, I have a diagram to show you. So as per the diagram, as per the statement, we have a diagram. Let me just show you. So let us draw a battery here. Okay, and then I'll show you. So these are the two ends, terminal, these 2 points. Okay, A, B. Let us connect a wire. All right. Now the statement says that the potential difference across the ends of a conductor is directly proportional to the current flowing through it. So the potential difference across the ends of a conductor means this is one end of the conductor, this is the wire. The wire is the conductor, remember? Wire means conductor, conductor is wire only, okay? So this is the one end of the conductor, this is the other end of the conductor. Now, the potential difference across these 2 points, okay, the potential difference between wire A and wire B, okay? The potential difference across wire A and wire B depends on the current flowing through the wire. So if more current is flowing through, if more charge is flowing through, that means potential difference will be high. So on separating the value of potential difference, okay, we'll get a high value. Let's say we're getting 500 voltage. Potential difference we are getting 500. Why? Because the current flow is more. Charge is flowing more. That means potential difference across point B and point A is also high. But on the other scenario, what if, so same point, okay, then this is, now let's make it as X and let's make it as Y. Then this is the same, this is the battery, okay. Then here in the given second, only one current is flowing through, only one charge is flowing through. Now what do you say about the across these 2 points? Across these 2 points, the potential difference across point X and point Y, what can we say? Charge, so only one is flowing, so current is less current. That means potential difference will also be more high. Less will be low, so maybe it's just 50 volt. Potential difference is just 50 volts, okay. Why is less current flowing here? Less current is flowing here, less charge is flowing here because the push is low. So the potential difference, the push, okay, is low. That's why charge is slow. So in a given time, only one charge is passing through. In the above case, the push is high, so more current is flowing through, okay, more current is flowing through. So more current flowing through, that means because the push that the electrons receive, the push that the charge receive was strong, that's why was high, that's why current is in that short, once again more current is passing through. So by looking here, okay, by looking at the amount of current flow in the wire, you should, using Ohm's law, conclude that potential difference across the conductor, which is across point A and point B, is high. That's what Ohm's law is telling us. And if the current flow in the wire is low, then using Ohm's law, you should conclude that the potential difference across the 2 ends of the wire, which is X and Y, is low. So remember, amount of current is directly proportional to potential difference. Vice versa, potential difference is directly proportional to current. Are we clear? Are we clear? Yes. Okay. Yes. So this is Ohm's law. Very simple law, but not so easy also, nah? Okay. But I hope you understood. Okay. So Ohm's law, mathematically we can write like this: V is directly proportional to I, where V is potential difference and I is the current. Okay. Then V, now we have to remove this sign of proportionality and bring equality. So remember this, my dear students. Some of you have confusion over this. Let me tell you, let me take some more time and explain to you. In physics, whenever, okay, we change the sign of proportionality to equality, this is called the sign of proportionality. This is called the sign of proportionality. And we change the sign of proportionality to this sign. This is called the sign of equality, which is used in mathematical equation, is not? These are two different things. This is the sign of proportionality, this is the sign of equality. Now I will be changing the sign of proportionality to the sign of equality. So I'm going to convert this symbol to this, which is a totally different symbol. Am I allowed to do this? Okay, actually, I can do this. So I'm doing it. But there is some small, okay, we have to bring something, okay, then only I'll be allowed to do this. Directly if I write like this, okay, this is wrong. This is totally wrong. So how can I make this correct? By bringing a constant. So I can make this, I can use this symbol instead of this, okay, I can replace the sign of proportionality and use equality provided I bring a constant. So I'm going to bring a constant R. So you will write here. So you will write here where R is a constant. Okay, and R is resistance. Okay, remember R is resistance. We'll be talking about resistance in the upcoming topics. So R resistance. What is resistance? Let me just give you the answer verbally. Resistance is the property of a substance to oppose the flow of current. So current wants to flow towards me. If I am resistance, then I'll oppose the flow of current. So this is called resistance. Resistance is the property of an object to fight back against current. This is called resistance, all right? So this R is resistance, okay? So finally, so this is Ohm's law, okay? Okay, and this resistance unit of resistance is ohm. Okay, the unit of resistance is ohm. You can say the SI unit of resistance. The SI unit of resistance is ohm. Okay, the SI unit of resistance is ohm, and then it is represented by the symbol like this. This is called omega. Omega. All right. So this is everything about Ohm's law. I suppose I have not forgotten anything. Okay. So my dear students, this is Ohm's law. Okay. So I hope you understood. So okay, it's not difficult. Okay. You can always go through. You can always rewind the video and watch. Okay. And then I guarantee you will understand. Okay. If you understood potential difference, then Ohm's law is very easy. So if you do not understand potential difference, kindly go and revisit the video and understand potential difference, the relationship between potential difference and current. Okay, then it will be very clear, very easy to you. Okay, so that is an appeal that I would like to make to you. Okay, my dear students. Now, before I say goodbye to you, okay, for this video, not a permanent goodbye. Okay, this is not a permanent goodbye. This is just a temporary goodbye. Okay, not a permanent goodbye. Okay, I'll be seeing you again. All right. So, question. Okay. We have already studied the state symbol. So I'll give one state symbols. I'll just draw the symbol, and you kindly comment the answer. Okay, identify the symbol and give the answer in the comment box. Okay, it will be much appreciated. So, tell me what is the name of this component. So, identify the component. So answer in the comment box. Answer in the comment box. So that's it, my dear students, and I thank you all for tuning in and learning. Okay, so I'll see you again in the next video. Until then, take good care, and may the Almighty God bless you all.